For what value of d is the sum to infinite terms of the following infinite series is 15 over 8. Let us begin. So here we have an infinite series. So let's denote the sum as s infinity. So it's given as 1 added to 1 plus d multiplied to 1 over 5 added to 1 plus 2d multiplied to 1 over 5 squared added to 1 plus 3d multiplied to 1 over 5 cube and the rest of the terms, where it's given that this sum as to infinity, it's 15 over 8. Fine. Now, this series is neither an arithmetic series nor a geometric series, because here we cannot define its common difference and also we cannot find a common ratio. However, it is composed of two types of sequence. One will be an arithmetic sequence and the other will be a geometric sequence. So here we can say that 1, if we consider the first term to be 1, then the next term to be 1 plus d, third term to be 1 plus 2d, the fourth term to be 1 plus 3d. Clearly, these terms are in arithmetic progression. And then we have, from the first term, let's take 1. From the second term, we're going to consider 1 over 5. From the third term, we have 1 over 5 squared. And from the fourth term, we have 1 over 5 cube. And the rest of the terms, these terms are going to be in geometric progression with the common ratio equals to 1 over 5. Okay, now as we can see, each of the term is a product of the consecutive terms of the corresponding terms of the AP and the GP. Now, what we'll do, we're going to take the sum of the infinite terms and we're going to multiply each terms with the common ratio, which is 1 over 5. So we have 1 over 5 times the sum of the infinite terms, so that's going to give us, so the first term we have 1 multiplied to 1/5 is going to give us 1 over 5 added to, coming to the next term, we have 1 plus d times 1 over 5. When we multiply it with 1 over 5, that's going to give us 1 plus d multiplied to 1 over 5 squared added to, next term is 1 plus 2d multiplied to 1 over 5 squared. So when we multiply with 1 over 5, so that gives us 1 plus 2d times 1 over 5 cube. And this is going to continue. So what we'll do, we will take the sum to infinite terms and from here subtract 1/5 of the sum of the infinite terms. So we'll keep the first term as it is. Next, what we'll do, we'll take the second term of s infinity and from here subtract the first term of 1/5 of s infinity. So 1 plus d times 1 over 5 minus 1 over 5. So that's going to give us d over 5. Then what we'll do, we'll take the third term of s infinity and from here subtract the second term of 1/5 of s infinity. So that leaves us with d over 5 squared. And the next term will be d over 5 cube and we have the rest of the term. Okay, fine. Now, on the left hand side, we have for 4 over 5 multiplied to s infinity. This will be equals to 1 added to. Now, if we observe here, we'll see that the sum of these terms is going to give us a geometric series. This geometric series we can easily obtain because we know its first term, that's d over 5, and we know its common ratio r, so that's going to be 1 over 5. And we have a standard formula for obtaining the sum of the infinite terms of a geometric series. So that's given by the first term divided by 1 minus the common ratio, which means that we have d over 5 divided by 1 minus 1 over 5. Let's further simplify. Now we have 4/5 of the sum of the infinite terms equals to 1 added to d over 4. However, in the problem, it's already given that the sum to the infinite terms is 15 over 8. So let's replace this value with 15 over 8, the sum. So we're 4 over 5 multiplied to 15 over 8. That's equals to 1 plus d over 4. So we're 4 times 1, that's 4. 4 times 2 equals 8. Then we have 5 times 1, that's 5. 5 times 3, that's 15. That leaves us with 3 over 2 equals to 1 plus d over 4. Now let's solve for the value of d. We have d over 4 equals to 3 over 2 minus 1. The d over 4 that will be equals to 1 over 2. So that means d equals to 2. So this is the value for d, so d equals to 2, such that the sum to infinite terms of the given series, that is for 15 over 8.